Good morning, everyone. Today we're going to start solving exponential and logarithmic equations. Okay, so let's get started with this. All right. Now, again, I kind of talked about it a little bit in the previous video when we were talking about exponential equation. And I would refer to something called the Voorhees method. And many students were asking me, well, gee, what are you talking about when you're talking about Voorhees method? Okay. So what I mean is when we're getting to the exponential part, we're going to focus kind of like on this area right here of Jason's hockey mask. Okay, and again, I'll go back and talk about that in a little bit. All right, so let's take a look at our first equation. Okay, now notice we have a fraction here. We can't have that, so we're going to need to move this 2 up to the numerator here. So we're going to use a negative exponent to do that. So we're going to have 4 to the x is equal to 2 to the negative first power, negative. And we're going to raise that to the x minus third. Okay, so because we have to have everything on the same level. Now remember, we're going to also have to we're going to have to multiply the exponents. Now since this is an algebraic expression, we have to distribute the negative 1 to both pieces. So we're going to have 4 to the x is equal to 2 raised to the negative x plus third power. Okay. Now remember, we now have to establish common power base. So between 4 and 2, my power base is going to be 2. So 4 I'm going to change because 2 squared is really 4. And that's going to be raised to the x is equal to 2 raised to the negative x plus third power. Now from here, we're going to multiply these exponents together. So power to power says you multiply, so it's going to be 2 to the 2x is equal to 2 to the negative x plus third power. Now, this is where I said before we're going to go Voorhees, and this is what I mean. Again, we're going to be focused on this part of Jason's hockey mask. More specifically, the triangle and the eye sockets. Okay. Now, what I mean by that is the triangle part of the hockey mask, we're going to put a triangle around the exponents and the equals. Okay, so exponent, 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 the equals is here. So that's the triangle. Now, for the eye sockets of the hockey mask, okay, is the bases. We don't need these anymore, so I'm going to scribble them out. That's what I mean by Voorhees method, okay? So we're basically, again, if you were looking at it, Jason's hockey mask, if I can erase all that, let's get rid of all that. So again, if we were looking at Jason's hockey mask here, okay, so we would have the exponent from the piece on the left at the top corner here, exponent of the piece on the piece on the right, and down here is the equals. So there's your triangle, and then the bases are going to be the eye sockets. Okay, so that's what I'm referring to as Voorhees method. Okay, so let's come back to our problem. I'm going to have to shrink that down a little bit. Okay, so now at this point, we're interested solely in what was in the triangle. So we're going to have highlighter, stupid. Sorry about that. Try this again. So we're going to have 2x is equal to negative x plus 3. And now you're just solving this equation. So we're going to add the x. And I'm going to have to shrink this again. So we're going to have 3x is equal to 3 and divide by 3. So x is equal to 1. And there's that one. Okay? All right, let's talk about the other one. Okay, so let's take a look at our next example. So again, first thing I'm going to do, okay, let's establish common power base since everything's where it's supposed to be. So between 9 and 27, now be careful, a lot of people want to say 9, but remember, 9 squared is 81. So we have to drop both of these down to base 3. So this is going to be base 3 squared, because 3 squared is 9, raised to the 2x, x. That's what I get for trying to do a video right after I drink coffee. Now 27 is going to be 3 cubed raised to the x minus 1. Okay, now let's go after these exponents. So we're going to have 3 to the 4x is equal to 3 to the 3x minus third, because I have to distribute that. Okay, so now that we have common base, okay, we've got our exponents set. Now this is where we go Voorhees. Triangle around the exponents and the equals, and cross it out. And again, if you're looking, see, there's Jason's hockey mask if I do something like this. Okay. But, so that's why I call it Voorhees. Again, you don't have to, but it was something fun, a little different. Okay, so now let's go after these exponents. So we're going to have 4x is equal to 3x minus 3. Okay, now solve the equation. So I'm going to minus the 3x. So I'm going to have x is equal to negative 3. And there's that one. See, pretty basic. And again, that's what I mean by Voorhees. Like I said, in a previous video, I had several people emailing, gee, what are you talking about when you say Voorhees? What does that mean? I was just referring to how this part here looks a lot like, it reminded me of Jason's hockey mask, that's all. So I dubbed it Voorhees method. All right, let's move on. All right, now, need to solve for the equation, okay? So we have 4 to the x is equal to 11. Now, unlike solving an exponential equation, we would normally start by establishing common power base. But the problem is, between 4 and 11, what would my common power base be? We can't answer that question because we don't have a common power base. Okay? So this is where we're going to use logarithm and the power rules to help us. So what I'm going to do is I'm going to drag this down. Okay? So I'm going to say x times log of 4 is equal to log 11. Okay. So now at this point, again, the power rule says I can drag that x in front. It's going to multiply with the log of 4. Now I'm going to since I'm showing x times log of 4 and I want to solve for x, I'm going to divide by log of 4. Therefore, x is equal to, now here's where your calculator comes in, and again, you're going to have to be very, very, very cautious with this. So again, you start with the top first. You start with this on your calculator. So you're going to do log 11 and hit equals. Now, depending on your calculator, some of you may have to type 11 and then hit the log button. Some of you will type log 11. It's dependent on your calculator. So again, right now, checking this, okay, you should get 1.04139268 for log 11. If you do not get that, okay, you have to punch it back into your calculator a different way, okay? And this is why using your own calculator is very helpful, so you know how this works, okay? For most TIs, or the graphing calculator and scientific calculator, you can type in log 11 and hit equals, okay? For some of the lower functioning TI calculators, you have to hit 11 and then hit the log button, and it'll come up with this. But even if you have to do it that backwards way where you do 11 then log, you still need to hit the equals so it separates what you're about to do next. So now, once you have this on your calculator, do not clear this answer from your calculator. Go ahead and leave the kitty alone. He's going to bite you. Right. Yeah, he is sweet, but it's except when you scare him. He doesn't like that. And divide by log 4. Okay, so we take this answer, we're going to divide by log 4 and hit equals again. So x is equal to, I get 1.72975. Hey, that's my calculator. Can I see the? Can I at least see the answer? Come back. Well, you get the idea here, because my 2-year-old Gwen just ran off with my calculator. So we have this. Now we're going to be rounding to 2 places. So this 9 says we're probably going to take that up. So we're going to do 1.73 as my answer. All right. All right, let's do this next one. I'll have to use my phone as a calculator here, so this is going to be rather interesting. Okay. Let's see. Hold on one second. Calculator. And again, if you're using your phone as a calculator, you're going to have to turn it on its side. Okay. All right, so here we go. Let's start this next one. So we're going to start, again, try to establish common power base.
Up.
What do you mean up? You stole my calculator.
No.
Yes, you did.
No.
Hey, but that's what's in your hand.
Up.
Oh, you want to sit up? All right, hold on one second, everyone. 1, 2, 3. Okay.
Give a kiss.
Oh, that's nice. Okay. All right. So, let's do this next one. Do you want to see?
See.
Okay. Hold on one second, everybody.
Yeah.
Yeah.
Calculator.
Yeah, see? Now everyone can see you got my calculator. All right, so here we go.
Buttons.
Yes, with buttons. Now, nice. Oh. Now, all right, so here we go. Let's start.
Down.
Yeah, so let's start. Let's take the log. So, because again, I want to take this exponent. I want to drag it down into the main problem here. So we're going to do x times. Ouch.
Down.
Yeah, you're down. Log of 9 is equal to.
Yeah.
We have log of 35.
Ouch.
Please don't break my phone and my calculator at the same time.
Yeah.
Okay. See? All right. Now at this point, now we're going to try to get that log of 9 away from the x. Log of 9.
Look, careful.
Okay, so we're going to divide by log 9. Shh, too loud.
Hey, Mom.
So therefore, x is going to equal to. So here's where your calculator comes in. Shh, easy, Gwen. Ugh, kids. Okay, so I don't need that anymore. She ran away. So let's get rid of that. All right, perfect. All right, so now on our calculators, okay, we're going to do the log of 35. So I believe on your phone you'd have to do it backwards. So you do 35 and then hit log, or log 10 from what I see here. You get 1, what did I do? I have, hold on, 1.55, or correction, 1.54. That's what happens when you're trying to do 6 things at once. So I have 1.54068044 and some change. And again, leave that on your calculator, because we're still got to divide that by log 9. Okay, so now on our calculator, we're going to divide by 9 log 10, and make sure you hit equals.
110.
110. X is equal to 1.61.
I feel.
You see what?
See.
You want to see me?
See me.
Well, I'll put it back in the next slide. 810863 and some change. And again, we're going to round to 2 places. Thank you. So x is going to be approximately 1.62-ish. Whoops. Come on, pen. And there we go. All right, let's look at another one. All right, so again, need for logs to solve the equation. So we have something like this. Okay, let me straighten that out. Looks awful. Okay, so let's get started. So again, first thing I'm going to look to do is try to establish the common power base, which I can't.
Calculator.
Yeah.
Calculator.
The calculator. So we're going to start here. Can't do much with power base. Shh, can't be yelling, honey. That's my job. All right, so again, we're going to try to drag this x down. So we're going to use log to do it. X times log 2 equals log 5. Okay. Now again, now we're going to try to get rid of this the log 2. So divide by log 2. No, don't push that. That keeps my pen on. So these cancel. X is equal to, thank you. X is equal to, we're going to have log 5 divided by log 2. A whisper. Okay, so now here's where the calculator comes in. So can I use my calculator? Thank you.
Give it to her.
All right.
Give it to her.
I guess not. All right, so here we go. So on our calculators, we're going to do log 5. So I'm using my phone, so I have to type it backwards. So 5 log 10. I get x is equal to 0.69 8669. Hold on. Got my daughter throwing my calculator at me, so hold on. 698970004 and some change, and that's still divided by log of 2. Okay, so now on my calculator, on my phone calculator, because that's all I got right now, I'm going to hit divided by. I'm going to do 2 log 10. And the calculator says 0.3010. That's not your answer. You still have to hit the equals after. And I get x is equal to 2.321928 and some change. Again, we're going to round to 2 places here. So x is equal to 2.32.
This way.
Okay.
Why off?
All right, let's look at the next one. A little bit more work to do in this next one. Okay. So again, try to establish common power base, but we can't. Okay. So we're going to take the log to drag this 9x down into the problem. So 9x times log 7 is equal to log 15. Now, just like we've been doing, we're going to divide by log 7.
Up there. How did I get down?
Okay, so this cancels. I'm left with 9x is equal to log 15 divided by log 7. So, 9x is equal to, okay, now on my calculator, okay, can I have my calculator?
Give it.
Give it? Okay, so no calculator for daddy, huh?
How?
Okay, there you go. So on my phone, because my 2-year-old will not give my calculator back. Okay, so we're gonna do 15 log. So I get 1.176091259 and some change, still divided by log of 7. Okay. So now my next step, I'm going to say 9x is equal to, so I'm going to take this answer and divide it by log 7. So 7 log. And again, my phone calculator says 0.84509. That is not your answer. You have to hit the equals. And I get 1.391662 and then a 0 and some change. But again, now notice I have 9x, not regular x. So I'm going to have to divide everything by 9 here. Okay, so when I divide by 9, I'm going to get x is equal to 0.154629, blah, 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 and some change. Okay, so rounding to 2 decimal places, x is going to be equal to 0.15.
Calculator. Hello. Okay. Push a button?
Yeah, you can push buttons on a calculator, huh? Oh, shoot.
Oh, shoot.
All right, so there's that one. So again, we are ready to move on. All right, next one. Need logs to solve an equation like this one. All right, now notice we have e. So that means we're not going to be using regular log. We're going to use natural log. But notice also around the e to the power of stuff, we have all this other garbage here. We got to get rid of that crap first before we can take a logarithm. Otherwise, this is going to get pretty ugly. So, just like we would if we were solving a normal equation here, first thing I'm going to do is I'm going to start by adding the 7 away. Ow! That's what happens when your kids throw your calculator at you. Yeah, but still don't throw my calculator at me. 4e to the negative 0.3x is equal to 20. Okay. Now we got to get rid of that 4. So I'm going to divide by 4s. Thank you. Hopefully you didn't break it. Good, you didn't. Okay. Oh, you okay?
No.
Okay.
I'm smelling pen.
You're smelling the pen. That's great. 0.3x is equal to 5. I'm trying to teach people.
I teach.
Yeah, so you need to be quiet. So now, just like before, we're going to try to drag this down. So we're going to use a logarithm. So negative 0.3x. Okay, so we're going to have this x times the natural log. So ln of e is equal to the natural log of 5. Okay, now just like we would with a normal log, we're going to divide by the natural log of e. But as most of us know from many of the earlier videos, natural log of e is just going to be 1. But again, I'm just going to be systematic here. Okay, so I'm going to shrink this. Okay. So you're going to have negative 0.3x is equal to natural log of 5. Yes, you threw my phone at me. Thank you. Okay. The fun of teaching math with a 2-year-old running around is so fun. So negative 0.3x is equal to, so we're going to do the natural log of 5. Now that I have my calculator back, natural log of 5, I get 1.609437912 divided by the natural log of e to the first. Oops. Wow. I don't know why that's separated, but okay. Okay. So now divide by natural log of e raised to the first power is going to be, oops, I forgot to do the previous answer. But again, divided by this, you know it's 1, so you're going to have 0.3x is equal to 1.609437912 and some change. Okay. Now, oh, thank you.
A pickle.
Yeah.
A pickle.
So now at this point, now we're going to solve the equation and divide by negative 0.3. Okay, oh, forgot the decimal point. Let me shrink this. Hopefully it'll all shrink together. Yep, there we go. So divide that by negative 0.3. I get x x is equal to, I get negative 5.364793.041. 1. Now rounding to two places, x is equal to negative 5.36. And there's that one. Alright, so let's move on. Alright, now, solve equations when logs are part of the problem. Check your answer afterwards. Alright, so here's where we have to start worrying about extraneous root. Okay. I already gave you a new diaper. Alright, so again, first thing I notice here, I have log base 5 of 4x minus 7, log base 5 of x plus 5. Now the nice part is, what we're going to do is we're going to start, I need to get rid of the logarithms first. So I'm going to give this a new base, which is kind of weird. So we're going to make these guys now exponents. So we're going to make these the exponents, and I'm going to go, since I have base 5, I'm going to make this now 5 to the log 5 of 4x minus 7 with log 5 raised to the log 5 of x plus 5. I give it a new power base. And the reason why I'm going to do that is because now this garbage will cancel and this garbage will cancel, leaving 4x minus 7 is equal to x plus 5. Shh, Gwen. Shh. And now we're going to solve the equation. Okay? It's going to start by minusing the x. So 3x minus 7 is going to equal to 5. Going to add the 7s. So 3x is equal to 12. And divide by 3. So x is equal to 4. Now, like it says, when we get to advanced stuff like this, where we're taking these and raising to a new power base and all that other stuff, you should check your answers. Okay? So let's go back. What we're going to do is we're going to put the 4 back into the original problem, which was this piece up here. Okay? So we're going to do log base 5 of 4 times 4 minus 7 is equal to log base 5 of 4 plus 5. And we're going to see if this works out. So we do log base 5. We're going to have 4 plus 4 is, or 4 times 4, sorry, 16 minus 7 is equal to log base 5 of 9. Okay. Now, let's do this. So log base 5 of 9 is equal to log base 5 of 9. Okay. So now, this looks okay because, again, one big thing we have to worry about is getting a negative in a logarithm, because we can't have negative in a logarithm. Okay. So in this case, does log base 5 of 9 equal log base 5 of 9? It does. And again, I don't have negative inside here, so we know we're good. Okay, so therefore, we're good. So the 4 does check out. All right, so now so there's that one. So I'm going to kind of pull this aside so I can come back and blow this back up. Shh, Gwen, you got to be quiet.
Nana, wake up!
Nana's awake. All right, now, for this next one, again, notice how this has log base 5, but this doesn't. We're still going to go to create a new power base of 5 to make sure that we can get rid of the logarithm. So this becomes 5 raised to the log 5 of 5x minus 1 is equal to 5 cubed. So in doing so, this cancels. So I have 5x minus 1 is equal to, now 5 cubed is 125. Now we're going to add 1 to solve the equation. So 5x is equal to 126. And divide by 5. So I get 126 over 5. Okay. So now let's do this up. So x is equal to 126 over 5. So now at this point we got to do our check. So log base 5 parenthesis 5 times 126 over 5 minus 1 is supposed to equal to 3. Now, believe it or not, the checks on these are much nicer to do because we can do our loop-de-loop later, and I'll show you what I'm talking about. So now, I'm going to take care of this. These cancel. So we have log base 5 of 126 minus 1 is equal to 3. All right, so let me shrink this down. Okay, so let's do this up.
You don't have to watch me or anything.
Base 5 of 125 is equal to 3. Now I'm going to do my loop-de-loop here. So, is 5 cubed equal to 125? And the answer is yes. So we know we're good. So we can keep our answers. Okay? Alright, so let's check out when these get even more fun. Alright, so something like this. A lot of fun. And it's even written in expanded form first too. So, first thing we've got to do, let's clean up this mess. The expanded form. Now again, remember the plus in between means these are multiplied together. So that what this really says is log base 10 of 2x times x minus 5 is equal to 2. Okay. Now what I'm going to do, I need to get rid of this logarithm here. So since this is base 10, because I couldn't see the 10, we're going to give these a new, this stuff up here is now going to become an exponent, and we're going to give it a new base of base 10. So by doing so, these cancel. Okay. So we're going to have 2x times x minus 5 is equal to 100. Because 10 squared is 100. But now we have to solve this. Which means because this side over here doesn't equal 0, I have to multiply these pieces together. So I'm going to get 2x squared minus 10x is equal to 100. Now it gets even more fun with this because since I have a square and it's not going to go away, we have to factor to solve this, which means we need to make one side of this equation equal to 0. So I'm going to minus the 100. 2x squared minus 10x minus 100 is equal to 0. Now from here, I'm going to start factoring. So I'm going to start by taking out GCF over here. So I could take out a 2. Leaving me x squared minus 5x minus 50 is equal to 0. Now again, I'm going to put the GCF in a big red balloon, and it's going to float away for a while because they all float down here. And I'm going to focus solely on this. Now it's got 3 pieces with no leader in front of the square, which means I can use PS2. So my product is negative 50. My sum is negative 5. So 2 numbers that multiply to 50 but subtract to 5 are going to be 10 and 5. And my signs are going to be negative 10 and positive 5. So we're going to have x minus 10, x plus 5 is equal to 0. And now this comes back as 2 in front. So now we're going to solve this. So remember, we're going to pull the piece apart. So 2 x minus 10, x plus 5. Set it equal to 0. Now we solve this. So 2 equaling 0. In the mathematics you're aware of, can 2 equal 0? Not that you know of, so this is gone. If x minus 10 equals 0, I add the 10. so x is equal to 10. Minus 5 on the x plus 5 equaling 0, so x is equal to negative 5. All right. Now we've got two answers. I'm going to kind of scooch this over here a little bit so I have room over here to work. Now we have to go back and check these two solutions. So I'm going to take my original problem, log of 2 to the x plus log of x minus 5, it's supposed to equal to 2. Log 2 to the x plus log x minus 5 is supposed to equal to 2.
What was the kind of stuff that I needed to
Now,
use for
let's start with the first one. I got 10, so x is equal to 10. Okay, so we're going to log 2 times 10 plus log 10 minus 5 is supposed to equal to 2. Now, so far, so good. Okay, I'm going to multiply this together. So we're going to get log of 20 plus log of 5 is supposed to equal to 2. Now, again, what I'm looking for here is making sure I don't get any negatives, because if I get negatives here, you can't have a negative with a logarithm. It doesn't work. You try it on a calculator, type log of negative 50, you get a domain error. It doesn't work. So since these are positive here, I'm good to keep going. So now with the plus here, I'm going to put this together as log 20 times 5 is supposed to equal to 2. So here, now put it together, log of 100 is supposed to equal to 2. And now I'm going to do my logarithmic loop-de-loop because I have base 10, because I couldn't see the base here. So I'm going to do, is 10 squared equal to 100? And the answer is yes. 10 squared is 100, so we know we're good. Okay, so this is a good answer. X equaling 10 is okay. Now let's go to the other side where it said the other answer I got was x is equal to negative 5. So let's plug it in. So we're going to start log 2 times negative 5 plus log of negative 5 minus 5 is equal to 2. 2. Oh, had to squeeze it in there. Now, when I put this together, I'm going to have log of negative 10. Log of negative 10 here is equal to 2. And there's where my warnings go up. I have a log of a negative. And again, if on your calculator you typed in log of negative 10, your calculator is going to say error. It can't be done. Okay? Because you have to think of it this way. Let's say I just focus on this chunk right here. Okay? And I say, oh, come on. So I just say, all right, I need log of base 10, negative 10 is equal to 2. Okay? Or actually, let's not do that part. Let's just say, let's make this equal to x. So we do our loop-de-loop. We're going to have 10 to the x is equal to negative 10. Okay? And I say, okay, we have to think about it. Well, 10 to what power gives me negative 10? And this is where I have students tell me all the time, oh, gee, that's easy. X is negative 1. No. Think about what an exponent does. Okay, let's go backwards. If I have 10 to the first, we all know that's 10. Okay. If I have 10 to the 0, that's 1. If I have 10 to the negative first, that's going to be 1 over 10. So you have to think about it. Is there an exponent here that I can raise to give me a negative 10 here? The answer is no. Even if you use fractional exponents, it's not going to work. Okay? So that's why if you wind up with a log alone with a negative number here, that's not going to work. So that's why we get error which means this x of -5 is not a good answer. You have to throw it away. So there's that. So the only answer you can have here is x can only be 10 for this to work. All right, kind of a lot there. So I'm going to do another one just like it so we can process this a little bit. All right, so let's go to the next question. All right, so I have log base 4 of x plus log base 4 of x plus 12 is supposed to equal to 3. So again, first thing I have here is expanded form. I don't like that, so let's put this together. So we're going to have log base 4 of x times x plus 12 is supposed to equal to 3. Now, at this point, okay, I need to get rid of this log of base 4. So I'm going to make this whole thing an exponent, and we're going to do a new power base of 4s to make this go away. Okay, so 4 of log base 4 cancels, leaving me x times x plus 12 is equal to, now 4 cubed is 64. Now we have to start solving this. So I'm going to distribute the x. X squared plus 12x is equal to 64.
What?
Minus the 64.
Rose,
X squared plus 12x minus 64 is equal to 0. All right, so let's start to factor this. Again, no GCF involved here, so I can go straight to PS2. My product is -64. The sum is +12. So two numbers that multiply to 64 but subtract to 12 are going to be 16 and 4. +16, -4. So I'm going to have x plus 16, x minus 4 is equal to 0.
Give it up.
And now we're going to pull the pieces apart. X plus 16. Oh, yeah, I wrote 12. Sorry, my dyslexia is kicking in here. X plus 16. X minus 4 equals 0 equals 0. And we're going to solve the equations. So x is going to equal -16 here. X is going to equal to +4. Now, one common question I get with this is, well, gee, if I get a negative answer here, can I just throw it away? The answer is no, because it all depends on what happens with our original function. If these were negative x's, then the negative and negative would cancel, creating a positive. So no, you cannot just throw away the negative. It's just in most cases, we're going to see that that will occur and we throw the negative away. But again, that's most cases, not all cases. So be careful on that assumption. All right, so let's pull this over here, because now we have to do our check. Oh, my pen shut off again. Okay, so let's split this. All right, so we're going to do when x is -16. We're going to do when x is going to be +4. Our original function, log base 4 of x plus log base 4 of x plus 12 is supposed to equal to 3. Log base 4 of x plus log base 4 of x plus 12 is supposed to equal to 3. All right, so substitute. Log base 4 of -16. And again, I see this right away, I can dead stop. I know not to go any further because I got a log of a 4 equaling a negative. This is over. Gone. Log base 4 of 4 plus log base 4 of 4 plus 12 is supposed to equal to 3. All right, now put this together here. We want to collapse the expanded form. So we're going to have log base 4 of 4 times, and then 4 plus 12 is going to be 16. It's equal to 3. So far so good, no negatives. Log base 4 of 64 is supposed to equal to 3. Now we do our loop-de-loop. So is 4 cubed equal to 64? And the answer is yes. So we know we're good. So the only answer I can keep is x is equal to 4. Okay? Alright, so that's the end of this video. Thank you for bearing with me between Gwen stealing my calculator and her screeching and yelling, throwing a calculator at me and everything else. So thank you very much for bearing with me, and I hope you learned a lot from this video, and I will see you next time.